Welcome to Jaysan Chemistry channel. Our next topic is going to be calculation of equal weights of different substances. In the previous video, we just learnt about the difference between atomic mass and molecular mass. Similarly, molecular mass and equal mass are slightly different from each other. We are going to learn how to calculate the equal weight of different substances. First, we are going to learn how to calculate the equal weight of an acid. What is the formula for equal weight of an acid? Equivalent weight of an acid is given by this formula, which is equal to molecular weight divided by its basicity. For acid, it is going to be basicity. Now, let us learn what is basicity. Basicity is the number of replaceable H plus ions present in an acid, right? The number of hydrogen present in an acid is different from the number of replaceable H plus ions that we are going to learn here. I am going to give the basicity of different acids here. I am going to give you some examples for that. Acids with basicity 1, 2 and 3. For basicity 1, we have hydrochloric acid, nitric acid, hypophosphorous acid, then we have perchloric acid, and so on. For acids with basicity 2, we have sulfuric acid, we have phosphorous acid, we have oxalic acid, and so on. Acids with basicity 3, we have orthophosphoric acid, or simply we call it as phosphoric acid. Now I am going to teach you how to find out the equal weight of different acids. First I am going to take the example of hydrochloric acid. What is the formula for equal weight? Equivalent weight of hydrochloric acid is equal to molecular weight of hydrochloric acid divided by its basicity. Now I am going to learn how to calculate the molecular weight of HCl. For hydrogen, the atomic weight is 1. For chlorine, it is 35.5. So for HCl, the molecular weight is 1 plus 35.5, which is equal to 36.5. So the molecular weight of HCl is 36.5. Whereas the equal weight of HCl is going to be molecular weight by basicity. What is molecular weight here? 36.5 divided by basicity. What is basicity? Number of replaceable H plus ions. In case of HCl, you have only one hydrogen. The number of replaceable H plus ions is also going to be 1. So the basicity is also 1 here. So 36.5 is the equivalent weight of hydrochloric acid. So the molecular weight and equivalent weight are going to be the same in case of hydrochloric acid, right? We are going to find out the equal weight of sulfuric acid. As I said to you earlier, it is going to be a dibasic acid. Its basicity is 2, which means the number of replaceable H plus ions is 2. Replaceable H plus ions is going to be 2 in case of sulfuric acid. In this case, the number of hydrogen as well as the number of replaceable H plus ions are the same, right? Equivalent weight of sulfuric acid is equal to molecular weight of sulfuric acid divided by its basicity. Now I am going to calculate the molecular weight of sulfuric acid. For hydrogen, it is going to be 1. For sulfur, it is going to be 32. And for oxygen, it is going to be 16. So its formula is H2SO4. Here you have 2 hydrogens. So 2 into weight of hydrogen is 1. You have only 1 sulfur. Weight of sulfur is 32. You have 4 oxygen. So 4 into 16. So what will you get? 2 plus 32 plus 4 into 16 is 64. You will get 98. In this case, what is the equivalent weight? Equivalent weight of sulfuric acid is equal to molecular weight. What is the molecular weight here? We calculated the molecular weight as 98. So 98 divided by its basicity. What is its basicity? Basicity is 2. So 98 divided by which is 49. So in this case, the equivalent weight of sulfuric acid is 49, whereas the molecular weight is 98. So in this case, molecular weight and equivalent weight are not the same. I am going to give you one more example. I am going to take phosphoric acid, H3PO4. Now here also the number of hydrogen and the number of replaceable H plus ions is going to be same. It is going to be 3. So it is a tribasic acid, which means its basicity is 3. Now molecular weight of phosphoric acid, or it is also called as orthophosphoric acid. We are going to calculate the molecular weight of phosphoric acid. For hydrogen, the atomic mass is 1. For phosphorus is 31. For oxygen it is 16. Now H3, here you have 3 hydrogen, so 3 into 1. Phosphorus, you have only 1 phosphorus, 31. 4 oxygen, 4 into 16, which is equal to 3 plus 31 plus 16 into 4 is 64. So it is going to be 98. So molecular weight of phosphoric acid is going to be 98. Right. Now I am going to calculate the equivalent weight. Equivalent weight is equal to molecular weight divided by its basicity. Now what is the molecular weight? Molecular weight is 98. Its basicity is going to be 3, because all the 3 H plus ions are replaceable. 98 by 3, which is equal to 32.66. So that is the equivalent weight of phosphoric acid. In this case also, the molecular weight and equivalent weight are not the same. Right? Now we are going to calculate the equivalent weight of the next acid. Now I am going to take H3PO3, which is phosphorous acid. In this case, the number of hydrogen is 3, whereas the number of replaceable H plus ions is not 3, it is going to be 2. So in this case, the basicity or the number of replaceable H plus ions is going to be 2, whereas the number of hydrogen is going to be 3. In the previous cases, we saw 3 acids: hydrochloric acid, sulfuric acid and phosphoric acid. In those cases, the number of hydrogen and the number of replaceable H plus ions were the same, but in this case they are not same, they are different. Right? Now what is going to be the molecular weight of this acid? Molecular weight of phosphorus acid. For hydrogen it is going to be 1 atomic mass, phosphorus 31, and for oxygen it is going to be 16. Here you have 3 hydrogen, so 3 into 1, you have 1 phosphorus. For 1 phosphorus it is 31. You have 3 oxygen, 3 into 16, so which is equal to 3 plus 31 plus 48. Now what is going to be the answer? Your answer is going to be 82. So in this case, the molecular weight of phosphorus acid is 82. I am going to calculate the equivalent weight. Equivalent weight of phosphorus acid is equal to molecular weight divided by its basicity. Now what is the molecular weight here? Molecular weight is 82 divided by its basicity. Its basicity is going to be 2 here. So 82 divided by 2, which is 41. In this case also, the equivalent weight and molecular weight are not the same. I am going to take another example, which is H3PO2, which is hypophosphorus acid. In this case, the number of hydrogen is 3, whereas the basicity is just 1. Right? Which means the number of replaceable H plus ions is going to be 1, whereas the number of hydrogen here it is 3. Now what is the molecular weight? Molecular weight is equal to, for hydrogen atomic mass is 1, phosphorus 31, oxygen it is going to be 16. So 3 into 1, for phosphorus it is 31 plus 31. You have 2 oxygen here, 2 into 16. So 3 plus 31 plus 32. So it is going to be 66 in this case. So the molecular weight is going to be 66. Now what is the equivalent weight? Equivalent weight is equal to molecular weight divided by its basicity. The molecular weight is 66. Basicity is going to be 1. So 66 divided by 1, which is equal to 66. So in this case also the equivalent weight and molecular weight are the same. Now I am going to give what is the reason for the difference in the number of hydrogen and basicity. We had 3 acids here, H3PO4, H3PO3 and H3PO2, and their names are phosphoric acid, phosphorous acid, and finally hypophosphorous acid. Right? Now for these acids, the number of hydrogen is 3 in all the cases. Right? Whereas the number of replaceable hydrogen, which is called as basicity, is not the same. In the first case the basicity is 3, in the second case the basicity is 2, and in the third case the basicity is 1. I am going to give why there is a variation in the basicity. Now I am going to look at the structures of these 3 acids. The first acid I am going to draw the structure here. Right? Now this is the structure of phosphoric acid, and this is going to be the structure of phosphorous acid, and this is going to be the structure of hypophosphorous acid. Now the reason behind the difference in basicity is this hydrogen. This hydrogen cannot be replaced. Similarly, these 2 hydrogen cannot be replaced. What is the reason for that? Because the affinity between phosphorus and hydrogen is very strong. So this bond is very strong to break. So this hydrogen cannot be replaced easily. This hydrogen that I have given in pink color. What about this hydrogen that I am going to give some other color like brown color, right? The hydrogen which is circled in brown color. Now in this case, this OH is attached to phosphorus in this manner, POH. Now there is no direct contact between this phosphorus and this hydrogen, because phosphorus is bonded to oxygen, oxygen is bonded to hydrogen. So this hydrogen, I am going to use green tick for this hydrogen. This hydrogen, which I have a green tick here, can be replaced because the hydrogen is not directly attached to phosphorus. It is attached to oxygen and oxygen is attached to phosphorus. So this hydrogen can be easily replaced, whereas the hydrogen that is directly attached to phosphorus cannot be replaced easily. So in the first case all these 3 hydrogen are replaceable, in the second case only these 2 hydrogen are replaceable, and in the third case only this hydrogen is replaceable. That is why the basicity is 3 here, 2 here and 1 here. The reason is hydrogen that is directly attached to the phosphorus has higher affinity, so that hydrogen cannot be replaced that easily. Our next topic is going to be equivalent weight of a base. Right? What is the formula for equivalent weight of a base? Equivalent weight of base is equal to molecular weight divided by acidity. For acid it is going to be basicity, for base it is going to be acidity. Now what is acidity? Acidity is number of replaceable OH minus ions, because a base contains OH minus ions, right? Now I am going to take sodium hydroxide, right? Sodium it is going to be 23, oxygen 16, and for hydrogen it is going to be 1. So 23 plus 16 plus 1, which is 40. Now equivalent weight of sodium hydroxide is going to be, molecular weight is 40. So 40 divided by acidity, you have only one OH here. So number of replaceable OH minus ions is 1, which is going to be 40. I am going to take another example, example 2. This is example 1 and I am going to take example 2 now. For example 2, I am going to take calcium hydroxide. What is the weight of calcium? 40, oxygen 16, hydrogen it is going to be 1. So 40, you have 2 oxygen, 2 into 16, 2 hydrogen, 2 into 1. So 40 plus 32 plus 2. What will be your answer now? 74 is the molecular weight of calcium hydroxide. Now equivalent weight of calcium hydroxide is equal to 74 divided by number of replaceable ion OH is 2 here. So 74 by 2, which is 37. So this is the equivalent weight. We have to find out equivalent weight of bases using this formula. So now I am going to take the equivalent weight of sodium hydroxide. If I take 40 grams of sodium hydroxide and dissolve it in 1 liter, it is a 1 normal solution. So I should take a weight equal to its equivalent weight and dissolve it in 1 liter so that I will get a 1 normal solution. Now, if I take 20 grams of sodium hydroxide and dissolve it in 1 liter, I will get a 0.5 normal solution. Right? Now, I want a 5 liter solution. I want a 5 liter solution of sodium hydroxide whose normality is 0.1. So how many grams of sodium hydroxide should I take? It's very simple. For 1 normal solution I need 40 grams. For 0.1 normal solution, that is 1 liter solution, how much I want? I want 4 grams of sodium hydroxide. Remember that, because the concentration decreases 10 times, which means the weight also should decrease 10 times. So 4 gram of NaOH dissolved in 1 liter will give you a 0.1 normal solution. Now I want how many liters? I want 5 liters. So multiply these two. So 4 into 5. So 20 grams of NaOH dissolved in 5 liter will give you a 0.1 normal solution. I think you will get the point now. For 1 normal, I need 40 grams. So for 0.1 normal, I need 4 grams. Right? That is 1 liter. I want to prepare a 5 liter solution. So multiply it by 5. 4 into 5 is 20. So 20 gram of sodium hydroxide dissolved in 5 liter will give you a 0.1 normal solution. Right? Next is going to be equivalent weight of salt. The formula for equivalent weight of salt is equivalent weight of salt is equal to molecular weight divided by charge on cation or anion. Say for example we can take so many salts. We will take magnesium chloride. What is the charge on magnesium? Mg2 plus 2Cl minus. So it has 2 plus or 2 minus. So we have to divide the molecular weight by 2 in this case. If it is going to be some other salt like aluminum chloride, here it is going to be Al3 plus 3Cl minus. So 3 plus 3 minus. In case of aluminum chloride, you have to divide the molecular weight by 3. So that is the formula for salt. And next it is going to be for an oxidizing agent or a reducing agent. I am going to give you an example for that. First let us see the formula for that. Now equivalent weight of oxidizing or reducing agent. For both you will going to use the same formula. What is the formula? Equivalent weight is equal to molecular weight divided by number of electrons lost or gained by the molecule. So let us take an example for that. Potassium permanganate in acidic medium reacts to give potassium sulfate, manganese sulfate and water. Right? Now here the oxidation state of manganese is plus 7. Here it is plus 2. So what is the change here? It is going to be 5. The change in oxidation state is going to be 5. So it has gained 5 electrons. So in this case, if you want to find out the equivalent weight of potassium permanganate, you have to divide the molecular weight by 5, because the number of electrons gained in this case is 5. we can take either the number of electrons lost or gained depending upon whether it is an oxidizing agent or a reducing agent.